Hello everyone, in this video we are going to discuss about Coulomb's law. Coulomb's law was proposed by a French scientist named as Charles Augustin de Coulomb, and according to him, the magnitude of the electric force between two-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Now, let's digest his definition, and we have two important points. According to him, force is directly proportional to the product of the two charges, thus we have this equation. Also, according to him, force is inversely proportional to the square of the distance between them, thus we also have this equation. Now let's combine these two equations or these two formulas. We will have force is directly proportional to Q1 and Q2, and this is inversely proportional to the distance between them, or r squared. Now our goal here is to remove this sign and to transform this into an equal sign. To do that, let's introduce a proportionality constant known as k, and this has a value of 9 times 10 raised to 9 Newton meter squared per Coulomb squared. Thus, our formula will become F is equal to k times the quantity Q1, Q2 all over r squared. And I know that this formula is familiar to you because we already discussed the universal law of gravitation, and the universal law of gravitation has the formula F is equal to G times m1, m2 all over r squared. Pretty similar, right? The only difference is that they have different proportionality constant, and in the Coulomb's law, it talks about the attraction between two charges, while in the universal law of gravitation, we talk about the attraction between two masses, for example, two planets. Okay, let's discuss more about this formula. F is the force of attraction between two charges, and your Q1 is the charge of the particle 1, and for the Q2 we also have the charge of particle 2, and for R it means distance between two particles. And of course, let's not forget our K, which is the proportionality constant. And this has a value of 9 times 10 raised to 9 Newton meter squared per Coulomb squared. So I think you are now ready to use this formula into a problem. Suppose that there are two charged particles. We have Q1 and Q2. And for, let's say that they have the same charges, which is 1.0 Coulomb, and this is another positive 1.0 Coulomb. So they are both positive charges, and they are separated by a distance of 1.0 meter. So R is 1.0 meters. The unknown here is the force. So let's compute for the magnitude of the force. So again, let's identify the given. So we have Q1 is equal to positive 1.0 Coulomb. Q2 is equal to positive 1.0 Coulomb. Our R is equal to 1.0 meters. And our K, of course, if this is constant, 9 times 10 raised to 9 Newton meter squared per Coulomb squared. And let's find for the force. So let's rewrite the formula. So we have F is equal to K Q1 Q2 all over R squared. Now we are ready to substitute the given into our formula. So our K is 9 times 10 raised to 9 Newton meter squared per Coulomb squared, times the quantity. We have Q1, which is positive 1.0 Coulomb, times another Q2, which is positive 1.0 Coulomb, divided by our R, which is 1.0 meter, and let's square this one. Okay, now let's simplify this equation. So let's rewrite K, which is 9 times 10 raised to 9 Newton meter squared all over Coulomb squared. So what is 1 times 1? Of course, we all know that this is positive 1 Coulomb squared. And this will be 1 meter squared. So we can cancel these units, meter squared and Coulomb squared. And our final answer will be 9 times 10 raised to 9 newtons. Okay, so when we compute for the force, always that our unit will be in newtons. So I guess that you understand our lesson for today. And if you have questions, just contact me through my messenger, or just comment or just post a comment in the Google Classroom. Thank you.